All right, so it is Tuesday. This is a great warm-up problem. What I'd like you to do is I would like you to pause the video, do this warm-up problem, find the domain, the vertical asymptotes, and then use logic to describe the asymptote behavior and the end behavior, and then restart the video once you've got those four things done. Check your answers, and we'll go from there. All right, so welcome back. What we've got here is, so we look at x minus 3. We set x minus 3, we set that equal to 0, and we get x equals 3. So the domain of this function would be all real numbers with the exception of x cannot equal 3. That's the domain. Because x cannot equal 3, that means we have a vertical asymptote at x equals 3. Remember, vertical asymptotes are set in line form, so 3 there is not enough to get the correct answer. Okay? Then what we're going to do then is we're going to look at, okay, so we've got this vertical asymptote at x equals 3, and I need to look at it coming from the right, and what the function is doing coming from the left. Okay? So if I think about smaller numbers here, smaller than 3, that would be like 2.99, let's say. It's going to be on that side. So if I put 2.99 into that function, or my f of x function, then that's going to be, hold on 1 second, I'm going to move this around. This up top, because then we can say, well, negative 1 divided by 2.99 minus 3 is going to be negative 1 over negative 0.01. Negative divided by a negative is positive. I've got a number divided by a small number. That means it's going to go to infinity. And this one's going to go to positive infinity. So my asymptotal behavior as x approaches 3 from the left, my function is going to be positive infinity. Now if I flip it over to the other side here, so now I would be like 3.01. I would have negative 1 over 3.01 minus 3. That's going to be negative 1 divided by positive 0.01. So that's going to be a negative divided by a positive. So that's going to be negative. And it's a number divided by a getting smaller and smaller number. So that one's going to go to negative infinity. So as x approaches 3 from the right, my function approaches negative infinity. Then I've got the 2, I've got as x out here is negative infinity, so it's a ginormous number. Okay, so then that's going to be negative 1 divided by a negative huge number minus 3 is going to be an even huger negative number. Negative divided by a negative is positive. So then my end behavior would be as x approaches negative infinity, my function is going to approach 0 from above because a negative divided by a negative is positive. And then lastly, if I'm way out here at x equals positive as x approaches positive infinity, my function is approaching 0 from below. And those, ladies and gentlemen, are the 6 answers that we needed to answer this question. Hopefully you got them right. If not, look back at the explanation for each one. So this question, again, very important to read the directions, find the domain and the vertical asymptotes. Okay, well, that's step number 1 on our cheat sheet or on our note sheet on our steps of what we're going to do to graph these problems every single time. And so far it's been take the denominator, x squared minus 9, set it equal to 0, and solve it. We could do this one of 2 ways. We could say, well, x squared minus 9 is x minus 3 and x plus 3. And then we could say that x minus 3 equals 0 and x plus 3 equals 0. We did a lot of this in unit 3. And so we get x equals 3 and we get x equals negative 3. Or we could have said that x squared is equal to 9, taking the square root of both sides. But when I'm solving and I take the square root, that's where that plus or minus comes in. I almost wrote plus or minus the square root of 3, but really it's just plus or minus 3. So the domain here for this one is all real numbers, but x cannot equal plus or minus 3. For my vertical asymptotes, there's 2 of them, and I have to list them separately. I cannot use the plus or minus when I'm listing my vertical asymptotes. I write them out separately. It'll take an extra 2 seconds, but we still write them out separately. Okay? And those are my domain and my 2 vertical asymptotes. Now on this one, again, we need to find the domain, vertical asymptote, and then use logic to describe what's going on. Okay? Well, to find my domain, I'm going to set my denominator equal to 0, solve it. X squared equals 25, so x is going to be plus or minus 5. I need 2 vertical asymptotes because I have a degree of 2 in there. So that means I would have 2 restrictions in my domain. So it's all real numbers, but x cannot equal plus or minus 5. Which means my vertical asymptotes are x equals 5 and x equals negative 5. Written out full on every single time. Don't get lazy. Okay? So now we're going to have to go do some logic here. So we've got 2 vertical asymptotes. So we got one at x equals negative 5, and we got one at x equals 5. Okay? So I'm going to have to go from the left on this one, the right on that one, from the left on this one, and from the right on that one. So I've got 4 different asymptotal behaviors to do here. So as x is approaching negative 5 from the left, what's my function going to do? As x approaches negative 5 from the right, what's my function going to do? As x approaches positive 5 from the left, what's my function going to do? And as x approaches as x approaches positive 5 from the right, what's my function going to do? let's start using some logic here. So over here, this would be like negative 5.01. So when I square that, it's going to be something a little bit bigger than 25. So it's going to have a negative number on top. So it's going to be negative 5.01 divided by a smaller number, because as I get closer and closer and closer, it's getting closer and closer to 25, but it's going to be a positive small number. Negative divided by a positive means on this side, it's going down to negative infinity. On this side, it would be like negative 4.99. So we'd have a negative 4.99 divided by, now that when I square negative 4.99, it's going to be just a little bit smaller than 25. So then this is going to be a negative. When I subtract 25, it's going to be a negative small number. Negative divided by a negative is positive infinity. On this side, now we're going to switch over to x equals 5. So now this would be like 4.99 here. So we would have positive 4.99 divided by a negative small number. So positive divided by a negative, that's going to be negative infinity. And lastly, over here we have like 5.01. So we end up with 5.01 divided by, squared is going to be just a little bit bigger than 25. So this is going to be a positive small number. And so that's going to go to positive infinity. So there's the 4 behaviors on the 4 sides of my 2 asymptotes. And then lastly, we would have our end behavior. That would be as x goes to positive infinity, my function is going somewhere. And as x approaches negative infinity, my function is going somewhere. Okay? So let's scroll back up here, get the function in the frame with us. So, I didn't use this color yet. So way over here at x equals negative infinity, I would have a negative big number on top, and I would divide that by an even larger positive huge number, because I'd have to square that big number, which is going to make it huge. So a big number, yes, it's still getting big up there, but it's getting bigger on the bottom more rapidly. So negative divided by positive, that's going to go to 0, but it's going to go to 0 from below because it's a negative number. And if I go way over here at x equals positive infinity, now again I would have a positive big number on top and a positive ginormously huge number on the bottom. Positive divided by a positive, that's going to be positive. So we're going to go to 0 from above. Okay? As of right now, your asymptotal behaviors are always going to go to either positive or negative infinity. That will always be true. As of right now, your end behaviors are going to go to 0. Tomorrow, when we change around our horizontal asymptotes, then our will not necessarily be going to 0 every single time. It'll go to a certain number. We'll figure that out tomorrow. Okay? With that being said, you can now do number 2 on this week's worksheet. Thanks for playing along. We'll see you in class tomorrow. Again, tomorrow is an optional day for virtual students, but feel free to join in either at 1 o'clock is the afternoon class or at 10 o'clock is the morning class. So 10 or 1, if you've got off tomorrow and want to join in live and soak it in, this awesomeness you can soak in live, and then you don't have to watch the video. More power to you. Have a great day.